Hi, this is Purnima Mahalingam, and you're watching video lecture series on power system protection and switchgears. In last topic, we are discussed about the operating principles of relays. Today, in this topic, we are going to discuss about the torque equation and RX diagrams. Come, let's go into the video. Here comes to the objective. So why we are going to learn this is to mainly to study the universal torque equation and to know the directional characteristics of the relay using the phasor diagram. So after watching this video, we can able to learn about the describing the operating principles of the relay using the universal torque equations and define the maximum torque angle and explains the directional characteristics of the relay using the phasor diagrams. Okay, this is the main thing. Here comes the torque equations, universal torque equation. So this is what the universal torque equation. Torque T is equal to K1 into I square plus K2. K2 into V square plus K3 into VA cos theta minus tau plus K4. So let's see what and all this. So K1 is the torque developed by the current coil. We know that we have current coil and voltage coil. So K1 is the constant, which is the torque, which is developed by the current coil. And I1, we know that the current flows the current coil. And K2 is the torque developed by the voltage coil, and we know as the voltage. And K3. So K3 torque due to the directional elements, and VA cos phi minus theta. VA cos, we know that VA cos phi is not that we know that is power formula. And what is angle theta? There is angle between the voltage and current, and tau is the maximum torque angle. That is what the maximum torque angle. And K4 is the torque due to the spring, which is the torque force which is applied due to the spring. Okay. Now, let's coming to what is the universal torque equations. So the individual torque may be act in such a way that the close to the trip contactor or to oppose the close of the trip once it closes or which oppose the closes. The torque which tends to close, that is the trip contact, is called as the operating torque. We have a main two torque. What is it? Is the torque which tends to the close or trip is called as an operating torque, and the torque which tends to oppose the closing of the trip contact is called the restraining torque. We have a main two torque. One is operating torque, and the next one is restraining torque. Which tends to close is known as operating torque. Which tends to open, which is opposing the closing. Which tends to oppose the closing is known as a restraining torque. Okay. Now coming to what is universal torque equation. Here comes by assigning the positive negative sign to certain constraints and let other constraints be zero, then the operating characteristics equations of all types of relays can be obtained by using the torque equations. The quality which provide operating torque is assigned as a positive sign. The quantity which provides the restraining torque, which is assigned with the negative. We have an operating torque and a restraining torque. That the sign assigned is positive and negative. When it is stripped, that is positive. When it is refused to strip, that is a negative. Okay. Now coming here, it is, for example, for an overcurrent like K2, K3 is equal to 0 because of the absence of the voltage winding, the torque equations. So K3 to K3 is 0. The K2 is 0, K3 is 0. Multiplications will be 0. What happens? K1. So K1 is the current coil torque, is assigned as provided the operating torque. K4 is assigned as a negative as provided as the restraining torque. Then what happens here? It is here we can see, let us consider another example, simple impedance in which the current coil provides operating torque, voltage coil provides the restraining torque. So then what happens? It is assigned as a positive, it is assigned as a negative, and this is assigned as a negative. Then what happens? VI gets cancels. So then what happens? It is opposed as a negative. The torque due to the spring can be neglected when the relay is on the average of the operations. When taking the averages, then finally the torque equation is this. Finally, we have current coil and voltage coil torque. Okay. Now coming to the phasor diagram, what happens here? It is phasor diagram. Here, the torque is directly proportional to the flux produced by the voltage, flux produced by the current, and sine of flux plus theta. The torque is maximum when phi minus theta is equal to 90 degree, when the torque is 0, when phi plus theta. Phi plus theta is equal to 0 degree or 180 degree. When it is maximum, when maximum it is in 90 degree. When it is 0 or 180 degree, what happens? Phi plus theta is 0. 0 degree or 180 degree. When the torque is 0. Here what happens when it is maximum? At 90 degree, what happens? The torque is maximum. The torque is maximum at 90 degree. The torque is maximum 0 at 180 degree or 0 degree. So in 90 degree, we have an operating region. But this is in a non-operating regions. Phasor diagram of the directional element. Here also same. So plus or minus 90, and the display is more than 90 will remain restraints. The same thing. The same thing, same problems here, and we have an torque equation for that. Another line, zero line, the angle between the voltage current and the torque is directly proportional to flux produced by voltage current sine, and putting the torque equation. So for theta equal to 90 plus 90 minus tau, then we will be getting this torque equation. Now finally coming to conclusion, we have a basic foundations, what the need for torque equations and impedance contact and relay characteristics and practical importance and RX diagram, and we have distance relay equations, torque equations and zones of protections, and finally torque is relay action, distance relay impedance based, RX design trips, and key for exams industries. So these are the overall things today we are learned, and thank you for watching. Thank you so much.